Please, can anyone hear me? All right, thank you so much. Thank you for joining to this section. I believe you have an awesome day today. So I wouldn't be doing intro on our community, because I believe everyone here is on the community platform. The names are so familiar. So while we kickstart today's lightning talks, the last lightning talk in July, the topic for today's section is modern Java 10 features every Java developer should know. Yeah, so it's something we might likely know, but then we will be getting a different perspective about it tonight. So I encourage us to stay put and learn. Adesola, is this your first time joining our section?
No, this is well, maybe this is my first, but this is not my first time joining like a meeting organized by NAIJA-Java User Group.
Oh, okay, welcome. All right. So without wasting much of our time, I want us to just react as I welcome the speaker of tonight's section. I think most of us are familiar with this guy. Most of us from DSA, to lighting sections, he has always been there back to back. So it's another night to dish from his dining table. So please, it's just Balogo that reacted. Yeah. Is it just Balogo that is on the call? Maybe other persons are far from their system. Okay. Thank you, Felua. Olayinka. Oh, okay. Okay, Adesula, you've not reacted. All right, thank you very much. So, Ebube, you can have the floor. Let me send my own emoji as well.
All right. Thank you so much, Gloria, for that wonderful intro. So, good evening, everyone. My name is Ebube. I work as the backend engineer for a company I shall not name. Yeah, and I'm also an admin for the NAIJA-Java user group. Okay, so today we're going to be talking about modern Java, specifically 10 key features that have quietly changed what it feels like to write Java day to day. So if the last time you really took a close look at the Java language was in the Java 8 days, when you're getting your certifications and all that with Lambda streams, and you're going to be in for a lot of surprises because Java has moved on a lot since then. And I believe it has moved in a direction most of us actually want. Less boilerplates, more expressiveness, more of that functional goodness. So, and then we have virtual traits. So yeah, with that. Okay, so my plan for the next half hour is simple. We'll go through 10 features one at a time. Each will be a small code example and a plain English explanation of what it actually gets you. Then at the end, I'll give you a quick preview of what's coming in JDK 26. I don't know if you guys are aware, but the project Valhalla spans a couple of JEPs. So they're going to be releasing it little by little, slowly until hopefully we finally get no safety in Java. And then we'll do a short virtual lab to some of the older foundations that are already there, but some of you may not be familiar with. So let's get into it. So modern Java, 10 features every Java developer should be using, from var to virtual threads. Okay, so here's the full lineup. We'll start with var and local variable type inference, because that's what it's majorly used for. Then we'll move to records, text blocks, which expressions, and the two pattern matching features, one for instance and one for switch. After that, we'll look into still classes, virtual threads, string templates, and how to build forms that one comes with an asterisk, which I'll explain when we get there. And finally, we'll look at sequence collections, which I'm sure many people are not super familiar with. Okay, so a quick disclaimer. If at any point you're unable to see my screen or unable to hear me, please send an emoji or notify me so I don't get ahead of myself.
All right.
Okay, so the first one, the var keyword. So var is mainly used for local variable type inference. So basically, if you remember in the old Java days, you'd have to write the type of whatever variable you're inferring twice. Like, okay, the old way of writing this would have been like this. So you can see there's a bit of repetition. I'm writing every string on the left and writing it on the right. So while it's explicit, but it's very verbose and kind of redundant. So with the var keyword, the Java compiler is smart enough to infer that the name is an array list of strings. So there are some little limitations on what you can do it. The compiler has to be able to know what the type is ahead of time. So we can't really use var everywhere. So the benefit is that it codes boilerplates on long generic types. You don't have to write it twice. And then again, take note of this, it's only for local variables with an initializer. You can't use this on fields and parameters. And
Sorry, Ebube, why is he speaking? Because you're muted.
yeah, so sorry about that. So the so again, you can't use it in fields or parameters because again, the compiler has to be able to know ahead of time what the variable is. So now there's really no way for it to know what name is going to be. So it's only in local variables that it becomes useful. And then you can't also use it for function parameters. Like if you see here in the args keyword, I'm supposed to find that this is an array of strings. I'm not using the value here. So again, only for local variables with an initializer, not everywhere. Okay, so next up is records, which was introduced from Java 16. So if you've ever written a plain data class in Java, for those of us who use Spring Boot or Devo, Jakarta, EE, we are using Wildfly or I think what's the new one, JBoss, yeah, so or Glassfish. You are used to using something like Lombok to make a data class in Java because Java didn't support data classes before. So you'd usually have something like I think I have you'd have yeah you'd have something like let's say public class of person. Then you'd have an annotation for those of you that use Lombok like this data. And what this will do is to generate getters and setters for the person class. You don't have to do it yourself to generate the two string methods and the equals and hash code methods for the class. But with Java records, you no longer have to do this. You have to use annotations. You don't have to use your ID to generate the getters and setters. You just mark it as a record. And that is all. My journey here. Okay, so you can see we have a record right here, a point record. And then what this does is that it generates the equals to method, the hashtag method, the string method, the constructors and the data accessors, that's your getters and your setters. And then an important thing is that the name for the getter is the same as the name of each field. So if I wanted to get x, as you can see here, yeah, I'm calling the function x. So that gets x, it's x. So the main use case of record classes is usually for immutable data. Like you won't use it for things that will need to change or mutate over time. So the most common use case you see this is inviting data transfer objects, where you are trying to decouple your database from the JSON request you send to the clients, or the ones you accept versus the one you actually insert into your database. So because we are generally doing is just initializing data, then using that data to initialize something else, you aren't actually mutating it directly most of the time. So record classes are perfect to just specify the contracts that these two interfaces will need. So now we are on par with um, data classes in Kotlin, or I think they're called record classes also in C Sharp. Okay, then text blocks. So this one has been around since Java 15, and it's very simple. I'm not sure many people knew about it. I myself I didn't know about it because it's every time like you are writing like raw string data. So to demo. So again, you don't have to keep writing new line characters in order to write a really long string or embed SQL or JSON. So one really good use case of this is if you are still writing raw Java data access objects, writing raw what's it called JDBC SQL statements. So you can just inline everything into a very nice long listen. I wish I could show you more. Other place you tend to see this now is in apart from normal SQL statements, is in Spring Boot's data GPA when you're writing JQL. That's I think Java query language for different databases or different ORMs to use. So when you realize that I don't have to add a new line character to show that this is a new line. So you just treat everything here as normal text, as if you're writing it into a text editor. So super useful. So if you're still using normal string classes, I'm doing something like select this new line from. So you no longer have to do that. You can just take your time and write it all. Okay, so switch expressions. This one has actually been around since Java 14, but not many people, I don't think many people know about this one because I still see in so many code bases normal Java switch statements, not expressions. So again, the difference between an expression and a statement is that an expression will return a value to yield a result, while statements do not. So switch becomes an expression, returns a value. So there are also some little gotchas in how it behaves because it behaves a little bit different from the normal switch statements. And then the syntax is actually, to me, a lot nicer because you have this cool arrow type syntax similar to JavaScript and all the cool modern languages of today. And then the compiler checks exhaustion, so it checks that it catches every single possible case in the switch expression at compile time, so you don't have to run and guess. and you don't have a situation where you have to put break. Okay, let me share an example. So initially, if you're using normal switch statements, you'd have to, I don't know if I remember how to write them. You'd have to write break whenever you're writing your switch statements. It will be something like switch. Please forgive me, this is not really accurate. Switch case Ebube. I don't think this, but I don't think it's entirely correct. But just to show my point, do this, and then you have a break statement. If you don't have a break statement, once it matches this one, it won't jump out of the switch statement. If you just go to the next condition, so this break is really, really important. And if you're like me, you're probably forgotten to add it a couple of times, and you stayed the whole weekend debugging while the behavior doesn't work the way you expect it to. So with switch expressions, it is way, way nicer. Again, you can see the nice ALU syntax over here. And then we can group multiple values. In this case, writing an enum. And then you can see that after you're assigning the value to this latest variable. And see our good friend debug code informing the type. So it already knows that this is an int. So again, super, super useful, super, super clean. So if you're still using Java, those switch statements which break, please don't, because they're ugly and the behavior tends to get messy over time. So moving on, we have pattern matching. If you have not used something like C#, I think C# is what made this very, very popular. You don't know how sweet pattern matching is. C# or I think Erlang. Was now maybe cool language than I think pattern matching. But I think it was C# that really pioneered it back then. So you no longer have to do tasks. I'll show you an example, okay, but let's go over what it does. So it's cast and bind variable in a single step. So why you're saying it's an F object is an instance of string, and then it's already doing S so it's already treating S as a string. Before you would have to explicitly cast S into a string before you can do this. The compiler was not smart enough to do that. While the language is like C#, because obviously this is true. That means S has to be a string. But formal Java could not do that. You still have to cast it inside this code block into a string before you could do that. So it was very redundant and ugly. So again, it casts and binds variable in a single step. So S acts as a string automatically. So it removes this very annoying exception. So very, very good developer experience overall. Let's look at an example. If I'm going to pass, please tell me. I'm not even running the examples. I meant to run them. So we'll do that now. So again, I'm saying if this value you pass here, remember, by using objects, the father of all classes of objects in Java. So it could literally be anything. I'm saying if value is a source of string. And in this, like you can see, nearly this thing is true. The value has to be a string. Before, what you'd have to do is do something ugly like this. Do an explicit cast over the before you start using it as a string. But now the compiler is super smart and you don't have to do that. You can see I've been using it as this as a string right here. So super, super, super useful. Super, super useful. Let's run this and see that it runs. Alright, but we should definitely work. And it obviously works. Moving on. So again, it could be in different parts. That variable s only exists in the places where the compiler can prove it's actually a string. So inside a block and anywhere else, the compiler can treat the same guarantee. Outside of that, it doesn't exist. So this removes the whole class developed with exceptions and improves developer experience overall. Okay, pattern matching with switch. This is another very, very sweet feature. Back before AI came and spelled everything, you'd enjoy this if you're writing it by hand. So this is pattern matching really like glows up. So pattern matching for switch was finalized in Java 21. I think that's the most popular LTS that everybody uses now. Though there is Java 25, but I think most of us are using Java 21. Not many of us have upgraded to Java 25. Maybe in a couple more years. Setting the sample, the describe method that takes a shape and then becomes a description. And you can see. So instead of routine of if statements, if shape is an instance of circle, else if shape is an instance of square, else if it is null. Yeah, so we can use the case and automatically just matches the pattern to each one and returns whatever value expression we have on the right hand side. So look how I mean you started about really like reading about this. This was not how it was before. Like you'd have to sweat and suffer more and type in more stuff before you could achieve this. Maybe using the instance of keyword. So this is about the case no shape rights writing the switch pattern matching. So it lets you switch null explicitly. You don't have to put it in an if block. And it doesn't like silently throw a null pointer exception, which is very, very famous in Java. So that's what should happen in case switch statements. Like this switch children was there before you get not switch expressions, but the thing will fall through and it was not catching more. So the thing is more exhaustive. I actually told you beforehand, so you can add it to your code and handle it properly. So less null pointer exception cases. Okay, so where this really shines is when you pair it up with the next thing we're covering, like we just glimpsed sealed classes. So when the compiler knows the complete closed set of possible types, a switch statement can a switch expression rather like this can be really, really exhaustive. So you can cast like all possible cases, and you don't even need that default case at the bottom because as you see, you already know every single possible case that can happen. So sealed classes. So C classes came in Java 17. Most of you have probably not used this. And for an application level developer that you are developing apps for normal laymen, human consumers, you may not actually need so much related classes. It's more useful to do if you're writing public APIs for other developers to use. So probably someone more in the lower space, kind of like those who do with reflection in Java. Okay, so it basically restricts exactly what classes may extend or may inherit or it may implement a certain type. So the compiler now knows the complete set of subtypes, the complete set of subclasses. So a switch over them can be very exhausting. You don't need to have a default to catch every other thing. And then one useful case, or rather the most common case of using field classes is in writing public API. Basically, you're writing an SDK for a service that you are maintaining. You could explicitly like make the class sealed and shield all the classes that inherit or implement it. And this will now prevent someone from extending your public class and messing with it. So that's where you tend to see this more often. You know, finally, if you look into Spring source code, or rather modern Spring source code, you see you see the pattern occurring. I think there's a need, but for the sake of being thorough, let's see a nice code example. Oops, we didn't cover. We didn't see them before. So again, we have a sealed interface. Again, you can have sealed interfaces, you can have sealed classes. Depends on what you're trying to protect. So I'm saying it only permits circle and square to implement it. So I can't come here and say something like record triangle right and see it to implement. Initially, you can see the ID is already giving me an error, and I'm going to go over and see it's let's see the class triangle is not allowed in this hierarchy. So let's say this is your public API, and someone wanted to just implement something on your class or interface to prevent them from doing that. So it's a security feature. And again, if you're doing this in switch expressions, you can see I don't have a case default here. I don't need to have that because it can only be a circle or a square. There's nothing else. These are the two things that are permitted for this sealed interface. So, for the sake of completeness, let's run that. Okay, Control H F5. What I just did. Okay, so sorry about that break in transmission. Sorry. Ooh, virtual threads. I think this is probably one of the most important ones. Oh, that this sense we can talk about virtual threads. But basically, they are lightweight. They are basically green threads. If you are familiar with green threads, like similar to what you have in Golang. I think what they could go routines in Golang. So basically, normal threads use OS level threads, which are more expensive. Like it's they're handled by the operating system, so it needs to allocate more memory for them. And basically, typically sold on the more factor. I think the default is like 2 MB per thread, so it gets very expensive. But virtual threads are very, very lightweight, so you can basically have millions running at the same time. The main usefulness of this is in writing IO working applications, which are basically so the bottleneck of your system is IO bound.
Ebube, please can you hear me? I'm
I
sorry
can, I
for
can.
yeah, sorry for interrupting. Are you using something like a speaker? Because your speech is not really clear enough. I don't know if I'm the only one having that issue. Can anyone else hear Ebube very well?
Was it?
Yeah,
Same.
you're right.
Yeah, so
It's
your
not very
speech,
clear.
the sound is not really clear
Is
enough.
it better
So
now?
yes, it is.
So I think I had ANC on its own. So okay. So thank you for informing me of that. Okay, so the main usefulness of virtual threads is in IO bound applications. So if your application is IO bound, which most applications are, That's where you really see virtual threads, because by default Java uses blocking um, system calls, blocking syscalls in reading files or transferring things via the network. But you have NIU, you have like the new input outputs in Java that was released later on to solve that. But most things already built on top of the normal IO. So you'd have to do, I think Spring, I've not done it for myself, but it's called Webflux in Spring Boot, or in the more modern ones use something called Vertex, which build on top of the new input output system, where you write non-blocking code by using lots of callbacks, or where you'd have to use computable features. But with virtual threads now, you don't need that anymore. You can write it as if you're writing normal threads, and what happens is that the JVM itself spawns lightweight threads itself that it manages by itself, so it doesn't hand over the control to the operating system. So the advantage is that you group a bunch of virtual threads to basically be handled by an operating system thread. So it will just be switching rapidly between each of them. So if one virtual thread blocks, let's say you're responding to a request from the clients and it blocks, the scheduler can just pick up another virtual thread and continue. So, and it happens seamlessly. So you no longer, for the most part, have to write reactive code or raw async code in Java. So it makes things very, very easy. Though there's a bit of gotchas on using virtual threads. You might be thinking, okay, we have virtual threads. Let's use virtual threads everywhere. What's new for two reasons? One is that there's something called pinning in but we don't have time to go into it now. There's something called pinning in virtual threads where a virtual thread can block the underlying operating system thread that's handling all of them. Usually, where you tend to see pinning happen is in synchronized blocks or in things that or where a virtual thread is handling a resource that's outside the control of the JVM itself. So then it actually has to run on an underlying OS thread. So if it blocks, that OS thread also blocks. So, and then you'd also not really use virtual threads most of the time for CPU bound tasks or managing your database pooling. You still need to use something like Utari to do it. So you're not is a tool. You have to know when to use it. But most application servers like Tomcat, Jetty, Netty supports virtual threads, and in Spring Boot it's literally very easy to enable it by default. It's just like adding something into your application.properties file, and then incoming request to just use virtual threads, which is a very nice use case for it. So good examples. I'm sorry if there's no exhaustive virtual threads, but there's literally so much you can cover on it. But key thing to note is that in Java 26, you no longer have pinning for synchronized blocks. So if you're doing any concurrency stuff, I need to access a shared data, mutable shared data, and you're using synchronized blocks to synchronize the threads. You can do that safely with virtual threads in Java 26 without causing a bottleneck in your application. So let's just run this. So again, the API is very, very friendly. You can see it's very similar to the normal executors dots. The normal executors dots. So look at how much I fixed it for. So the API is very, very similar. So again, you'd also have it in an executors block to manage everything for you. So yeah. So now this next one, I want to be sure to say about it because it's a little different from everything else on this list. So string templates were previewed on Java 21 and again in Java 22. And the idea was string interpolation. So look at the example here. You have the hello, and then this weird escape syntax a name, so you don't have to keep concatenating strings. You can just embed an expression directly inside the string literal. So, and then, so, but here's the truth. For Java 23 ships, all I could redo this, this JEP, the JEP that created. So, if you're not familiar with what the JEP is, it's basically stands for JDK Enhancements Proposal. So usually you have someone via the team when it's proposed, like it's not going to be implemented yet. I think when it's going to be implemented is when it moves to being as a GSF or GSP. I can't remember correctly. So basically, it was withdrawn before it could reach. So the studio reason was that there was no consensus on the right design, and that's one thing that they usually struggle with because like Java has to maintain a very strict contract of backwards compatibility. Yeah, so and they are very, very strict about it. We can't have code that you wrote in Java 2 should still run in Java 30. That's the idea. So to get everybody to be happy is very, very difficult. Even in the syntax they're proposing for null safety now, many people are still complaining. That's one of the reasons that the thing is still being delayed. Or by God's grace, it will surely come. So why am I showing this? It's because you might see the syntax reference in older blog posts or LinkedIn articles. Or maybe you see JDK21 and JDK22 code because when you're using the preview versions and you wonder what's happened to it. So, and the answer is it just never ships. And as of JDK26 project Valhalla, there's honestly no JEP. There's no new proposal for this. So you still have to be using concatenation or string dot formats. So, but at least you know why all of us are suffering to be writing plus. Okay, sequenced collections. So this came in Java 21, one of the best LTS versions in my opinion. After JDK, it's Project Lambda. But it's one of those features. Why didn't you have this already? Like, you don't understand that, like when you see it, you wonder like what took them so long. Okay, so before this, if you wanted the last element of a list, okay, I need to be showing this. Okay, see it's already written here. If you wanted the last element of the list, you would have to write something like links dot get dot just to read it. Like this is stress you have to undergo just to get the last element of the list. Like so, like other classes like the queue had their own separate methods for first and last. Some other data structures like linked as map didn't even have any for getting it at all. So you can guess about that. But now look at the example. You have nums will get first, nums will get last, methods for reversing the strings. So you have like one consistent API. So everything that basically implements that interface will behave the same way. So you don't have to try and remember which method works in which data structure. So it's not flashy, but it's kind of a small consistency that quietly removes a lot of little annoyance in writing everyday code. So that's all then. So let's shift gears and look ahead. So JDK 26. This is what has been announced that we know of. You notice there's no safety here because they're still deliberating on, like, they're still trying to agree on how it will look like, what the syntax will be, what the behavior will be, and how backwards compatible will it be. So by those grace, it will come. They're saying, I hope I see Project Valhalla before I get to Valhalla. Okay, so in JEP 530, you have primitive types, patterns. And I think that's one of the most important features is that you have like value types. So you no longer need to have like auto boxing of primitive types into the corresponding wrapper classes. Like the compiler will be able to like those bytes what to use. Like we have to it's like a big performance benefits. So there's no need for auto boxing where you convert the primitive type into the corresponding wrapper class. So you basically can use the values itself for most of it. So you can store on the stack. So less heap allocations, making everything more memory friendly and more performance. And structured concurrency is like this is like another big one. So basically, you basically group a set of related tasks, basically a set of related traits to have one underlying parent. So they can't outlive the scope of that parent. So when you kill that parent, every underlying children under it has to die. Everything that forked from there has to, because so you don't have like what's it called, zombie traits or zombie child processes. The Kotlin already has this is like one of the biggest advantages of Kotlin. Well, by those guys, it's coming to Java. That's why us not having any easy form of structured concurrency is why you have books like JCIP, Java Concurrency in Practice. And then lazy constants. We already have some lazy collections already, but it's this one just adds makes everything like more fire. If you'd forgive my words. Uh, so firstly, the report table values. So for fields I get computed once and the behavior is treated as if they are final. So on the performance side, you have ahead of time object caching, now works in any garbage collector. So basically, like most of us don't fine tune the JVM ourselves. So like you don't need to know much except you're in a situation where you have to pull up what's it called? Oh, TDK flight inspector or something. And actually look at like the performance bottleneck in the JVM based many applications. You have to vehicle API and you have support for HTTP3 in the client side. Languages like Go has the added sense. So we are catching up, and it's also a benefit to languages like Kotlin that run their code on the JVM. So now let's look backwards. Streams. This has to be like the best feature. Java Project Lambda for Java 8 is like one of the best things that happens to Java because we finally do functional stuff. And functional programming, for being as impractical as it is, it's very very developer friendly. The idea of knowing table states and having functions act as data itself. So again, we have things like the Stream API, functional interfaces, and just good functional goodness all around. We have the optional type, so like an algebraic data type. We don't have monads, as I don't think we have monads in Java, but this is nice. So it's reduced more pointer errors because if you're like you're fetching something from a database now, which a record that might exist or not exist, using optional, it's a very good use case. I tend to see it uh, in most, at least I know GPU uses it in Spring. That's what you have to do, or else do something else because it's optional. Like, well, there are some common gotchas in it. Since the fact that it's a class, it can still be null itself. So it's not as if it's strict. Then try with resource. There's basically things that you don't have to call clues on a resource manually. If you just put it inside a try with resources block, as long as that thing implements the auto-closable interface, it will just close it automatically. So it was a nice developer friendly feature. And it's when people see it code themselves manually. So collection factory methods, very, very sweet. I use this all the time. List of map of you don't have to manually start adding things into a collection list of add you can just it's just more readable. So just syntactic sugar for developers. Then Java the time API, which you can we can spend like an hour talking about this. But most of us already use this now. At least we are writing Spring Boot using local date time, and you have to know like there are differences. So it's more consistent. Then the diamond operator, um, because of this diamond operator now, you don't have to type. I think we had an example. Type array list, have the string in both cases. So this just helps to infer the generic type beforehand. A bit like how the var keyword works. So small syntax changes, big shifts in how Java feels. Divides. Now this just cover developer sides of things. There are still many performance enhancements and optimizations in the JVM that have been going on that have made Java a very, in fact, there are many cases where a Java program will run faster than something compiled in C++ because of the just-in-time completion. In ahead of time completion now, you need to compile everything ahead of time into the binary. But the benefit of just-in-time completion is that you can see the parts of your code that frequently run because it's not all parts in your code that's being taken. You get one thing might run more than other parts. So the let's say the Java runtime can see those parts and compile it into very, very fast machine code. Yeah, because like that's like the major parts that runs all the time becomes very, very performance. So do take note that if you're using something like Spring Native or the Grow VM to compile things ahead of time, you lose that hotspots JIT benefits. So you don't get the hot part of your code being compiled just in time. So you are basically sacrificing memory consumption for raw performance speed. So it's a good thing to note when you're going to use it next. So that brings us to the end of my talk. And I hope you guys learned something because I definitely did when I was preparing for this presentation. So thank you. Over to you, Gloria.
All right, thank you so much, Ebube. That was awesome, incredible. I believe most of us have learned something new tonight. Or am I lying? Please, if I'm lying, you can correct me. All right. So, in course of the presentation, yeah, Ebube already mentioned earlier that he's one of the Java user group admin. Yeah, but in course of the presentation, one one of the admin actually joined the section, and I want to introduce one of the admin. Mr. Amos is on the call. Mr. Amos, are you there? One of our backbone admin.
Yeah, I'm here. Good evening, everyone. Ebube, thank you so much for this wonderful presentation. Thank you, guys.
Right. Thank you so much. So, let's open. Okay, so this is an open floor for questioning. If there is any question, you can raise up your virtual hand. But I believe we have done a lot. But if there is something you still need clarity on, you can raise up your virtual hands. So is there no question? Ebube, why is it that whenever you take a section, there is no question? Okay, let's have a comment. if there is no question, let's have a comment. No comment as well. Are we all good? All right. Balogu, you can unmute and speak.
Yeah, I just want to mention that I love seeing Vim users. So shout out to Vim users. Oh God.
That's what I wanted to say. And thank you for the session, Ebube. I really learned something. And also, I was having some opinions about virtual trade, but that cleared up some things for me. So yeah, thank you for the session.
All right, thank you so much, Balogo. Is there any other person? I believe everyone here is on the Java user group WhatsApp. Yeah. So Ebube, do you have any question for them? Since they don't have question for you.
No, no, I'm good though.
Do you have for them?
No, I don't. I
Okay.
don't. I just hope they learn. I hope the reason they are silent is because I did justice to it. I know that they're not even hearing me or they're not understanding. Well, it's simple, sure. So I think everybody was really familiar with it. So it was just to get more light.
All right. So I believe party A, those that was listening, and party B, the one that was speaking, we are all on good terms. So Balog, hold on. I saw some new persons. Please, if today is your first time in our section, could you just raise up your virtual hand? I'm seeing some new names. Tolu, I'm seeing Tolu for the first time. Well, that's good. So Balogo, you can go ahead.
Okay. My question or my opinion would be about the var variable. That was the first thing that I presented on using the var keyword, right? So he said, well, one of the advantages is that it reduces boilerplate code, right? So I was also having a different opinion that just using var actually kind of reduces readability of the code. I mean the way that the code is kind of expressive, and coming from JavaScript, that's one of the many things that I appreciated about Java. Just being very expressive about what you are defining, what you are expecting, right? So in your own personal preference, I know people have different preferences, but I want to hear his own personal preference. Would you go all in on var, or do you still prefer the expressiveness that um, the explicitly stating everything gives in Java?
Okay, thank you so much. That's actually something I was hoping someone would see. Personally, when I learned about the vacuum when I was learning Java, I did not like it because, like you, I liked the fact that everything was very explicit. Like I like seeing things like this string, all of these h equals to 21. I like seeing things like this because I didn't need to think. But as I got more used to Java and I started doing DSC using Java, you get tired of writing things like this. Oh, sorry. I think a more meta feature would be using writing things like this. Let's do this. So you can see, you can argue that this thing is more readable, but you can also see that it's just unnecessarily redundant because I'm saying is an array list of things here. I'm also saying it's an array list of things. So even if I were to remove the use the diamond operator, I'm between these two parts. So I think, like most things in programming, is know when to use the right tool for the job. So for most things, when you can already tell, like on your own, like here now, I can always tell that this thing is and I really stop things from the constructor. So there's really no need. You can just infer the type, and then for basic primitives that everybody already knows, like everybody already knows that double quotes now is a string. So it's also safe to verify the type. But for more complex objects now, let's say you're writing your own classes. And okay, let me give you an example now. Let's say you have something like new. Though most of the time when you're using the new keyword, it's nice. Yeah, you can also infer the type since you already know it's going to give you an instance of that class. But if you have something like let me see, person dot so let's say this thing is returning an instance of the person, but you wouldn't really know. So in this kind of case now, it would be nice to explicitly state the type. So it's just knowing when to balance it. I don't think using var everywhere is a good thing. It's just like the arguments you see and using if blocks without the curly braces. Uh, so some people argue that for things where you just have one thing to do, you should not bother using the curly braces. I don't know if it gets. Yeah, you should just do this directly. But people argue that this up one is way more readable than this down one. So again, it comes down to personal preference, and most of the time it comes down to what your team and people you're working with like. So let's say you're somebody now that prefers to use var everywhere. But if you go into a team and the code base, everybody is using the older way of stating everything explicitly. It's just best to follow the convention there. So so developer, you have to adapt to where you find yourself in. So that's my own point of view.
Balogu, are you satisfied?
Yes. Yeah. Thank you.
All right. So apologies for exceeding the time. We'll be drawing the curtain for today's section at this point. But I want someone, yeah, to just tell me what will be happening next month. If you've been following us up, you should know what's happening next month. So that person, I wouldn't say what I want to give to that person, but let me aside the admins, yeah. Let me close with that. So I'm just going to give a count of 5. Then if nobody answers, I'm going back with my gifts. So I have 1 and 2, 3, 4, 4.5, and then 5. So nobody is going home with my gift. Oh my God. I'm so sorry, Shinaza. So NAIJA-JUG group will be +1 next month, and that is going to be our anniversary. Yeah. So for those that are not aware, a lot is going. Don't miss any of the section. I beg you. Don't miss any of the section. The lightning talks and the monthly. Don't miss it. There is a reason why. We meet again, same station, next week, Tuesday, and same time. Do have a lovely night ahead. Good night, everyone.